Hi folks, today we are going to talk about inverse properties. We started talking about them yesterday, and we're going to talk about composition of trig functions. So yesterday we went through all of the different inverse properties. I have them up on the screen here for you. I want to do a few more example problems just so you get the idea of how these work. So if you see problem A here, the first one, it says it's the composition of the cosine with the inverse cosine of 0.6. So if you look at the chart, right, this follows along with the one here where it says cosine of the cosine inverse of x. And it says that your answer here is x. And you get x as long as your x value is in the interval of -1 to 1. So in this first example, 0.6 does fall between -1 and 1. So your answer very simply to this problem is just 0.6. Okay, because it falls in that interval, you just get back whatever the x value was. In letter B here, this one is a little bit different. If you look at the problem, we're starting with the inverse signs. We have the inverse sine of the sine of 3 pi over 2. So that's going to take us up to the second one in our list here. And it says that it will return an answer of just x as long as x is between -pi/2 and pi/2. However, 3 pi over 2 is not. It doesn't fall between -90 and +90, right? 3 pi over 2 is actually 270 degrees, and that's not between -90 and +90. So what we need to do is start on the inside here and work our way out of the problem. So I first need to figure out what the sine of 3 pi over 2 is. So I have the sine of 3 pi over 2. Remember that 3 pi over 2 is on your unit circle. It falls right here on your unit circle. The coordinates of that point are 0, -1. And remember that the x-coordinate is the cosine of that angle, but the y-coordinate is the sine of that angle. So the sine of 3 pi over 2 is just going to be -1. So if I go ahead and substitute that in, I'm saying, well, what angle has a sine of -1? So now I have just a straight inverse trig problem, which is like what we were doing last Friday. And now I can say, okay, well, what angle? This is really saying what angle has a sine of -1, and I know then that that has to be -pi over 2 because that has to fall from -pi/2 to pi over 2. So the answer can't be 3 pi over 2 because it's not in the interval, but the answer is -pi over 2. In letter C, again, this follows this format here of cosine of the cosine inverse, or inverse cosine of x for x. The problem is that 1.5 doesn't fall between -1 and 1. And because it doesn't fall in that interval, that means I can't actually do this. If you think about it as well, this is really the part that's inside the parentheses here is saying, well, what angle has a cosine of 1.5? And if you do that in your calculator, if you were to go ahead and put that in your calculator, so let me clear that out. If I did second cosine of 1.5, I end up with an error in the domain because you can't, there is no such thing as an angle that has a cosine of 1.5. We actually talked about that. We said in a right triangle, your longest side is your hypotenuse. And so if the longest side is your hypotenuse and cosine is adjacent over hypotenuse, there's no way that ratio can ever be greater than 1, nor can it equal 1. So this doesn't even exist. It's not possible. So your answer to this entire problem is just that it's undefined because you can't do it. Okay? Let's talk about when we are doing a composition of different trig functions together. So for example, I have the inverse sine of the tangent of pi over 3. Okay, so I know that pi over 3 is in my 30, 60, 90 triangle, right? That's just 60 degrees. And so I say, okay, well then what is the tangent of 60? Well, the tangent of 60 is square root 3. So I can just substitute that in, square root 3. So when you have a composition of two different trig functions together, you want to start on the inside and work your way out of the problem. Okay, so tangent of pi over 3 is just root 3. And so now this is just a very straightforward problem. I'm saying the sine of what angle is root 3. And if I look at my triangle, the angle whose sine is root 3, well, oh, that's kind of hard to figure out there, isn't it? I don't really know what angle has a sine of root 3, so it doesn't necessarily apply to this triangle, does it? So what I'm going to need to do is do that in my calculator. And I can do that in my calculator very easily. I can just go to sine. Whoops, let me quit out of there. And if I just go ahead and I do the second sine of root 3, and hopefully you already kind of have an idea of what's going to happen here, because hopefully you recognize that root 3 is actually greater than 1. And so what's going to happen, I'm going to get that same error. Okay, so my answer here would be simply undefined again as my final answer. Okay, so even though I could do the first part, I couldn't do the second part. That's not always going to be the case. It may, in fact, work very well, but it might not. So it just depends on the actual problem. We're actually going to do a few more. Let's talk about a problem like this. So this is saying, well, what angle, so we're doing the cosine of the inverse tangent of 5 over 12. That's in essence what we're doing here. Okay, so I could ask you for a decimal approximation, or I can ask you for the exact value. And depending on what I ask you is going to depend on how you're going to do the problem. If I'm going to do the problem just very straightforward, if I'm going to do using the calculator, then I would start on the inside and work my way out. So I would say, let me quit out of there. So I would say second tan of 5 divided by 12. That's going to give me 22.61 blah, 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 right? I know that that is what the angle is, but now I have to take the cosine of that. So the cosine of my previous answer, and if I hit enter, then I would get the decimal approximation. That would be 0.923, I forget what it was, 0.92307, whatever it came out to be. Okay. However, if I ask you for the exact value, you're going to have to do a little bit more work. Basically, you're going to have to use right triangle trig to figure this out. What I mean by that is this. If you draw the problem out, here's your right triangle. It's my badly drawn right triangle. Here's your right triangle. And you say, okay, if this is my theta here, and it really doesn't matter where you put theta. You could put it up here or down here. If here's my theta, I'm saying the angle whose tangent is 5 over 12. So this is 5 and this is 12. Okay? Because tangent is opposite over adjacent. Well, now I'm just trying to find the cosine of that same angle. So if I just use right triangle trig, if you're not familiar with the fact that 5, 12, and 13 are a Pythagorean triple, you could simply do the Pythagorean theorem to find that hypotenuse, and you come up with 13. And so now I'm going to say, well, what is the cosine of my angle here? Well, the cosine is just adjacent over hypotenuse, so my answer here then would be 12 over 13. okay, it would be 12 over 13. So if it asks just for a decimal approximation or, round to the nearest tenth or whatever, you can just do it in your calculator. But if it asks you for the exact value, you need to do out the steps there. Let's look at this second one. This actually should say negative 1/3. Okay, so that is a little bit easier to read. This one's a little bit different because of the fact that this is negative 1/3. Okay, so and the only difference is how it affects your final answer. Think about this: the inverse sine function exists from negative pi over 2 to pi over 2. So because this is negative, that tells me that my triangle is going to be down here. Right here, I didn't draw it in the coordinate plane because I didn't have to because it was positive. If I did, all I would have said was, well, I know that inverse tangent exists from negative pi over 2 to pi over 2 as well, and because it's positive, I would have drawn it in the first quadrant. This would have been my theta. Tangent was 5 over 12, and I would have gotten 13. I still would have gotten the same answer. I just didn't draw it there because everything was positive. If you feel better drawing it like that, please do so. However, in this case, because it's a negative, I want to make sure that I put it in the right place so that I get the right answer. This has to be down here because it's negative. So there's my theta. Sine is opposite, so this would be negative 1 over hypotenuse, which is 3. I can do the Pythagorean theorem. I have negative 1 squared plus b squared is equal to c squared. I end up with b squared is 8. So b comes out to be 2 root 2. So this would be 2 root 2. It's on the positive side of the x-axis, so I know that's going to be positive. And so then the cotangent of my angle, cotangent just flips tangent. So instead of opposite over adjacent, it's just going to be adjacent over opposite. So my final answer here is going to be negative 2 root 2 over 1, or just negative 2 root 2. So if it helps you, make sure you draw it in the right quadrant. You really only need it if this comes out negative. And remember, with cosine, if the inverse cosine is negative, it's in the second quadrant. Okay, one more problem. This tends to throw people off when they see a variable instead of actual numbers here, but don't let it throw you off. Think about this for a second. Inverse sine function is positive in 1 and is positive in 1. It only exists in 1 and 4 here. So because it's positive, it has to be in the first quadrant. So if I draw it in the first quadrant, this is my theta, and I'm saying the inverse sine is x. That's the same as saying this is x over 1. So again, you could do the Pythagorean theorem to find that missing side. You have x squared plus b squared is 1 squared, and I'm rushing just because I'm going to run out of time here. So I end up with b squared is equal to 1 minus x squared. B comes out to be the square root of 1 minus x squared. So then that's what this would be, 1 minus x squared. And then the cosine is just adjacent over hypotenuse. So your cosine, or your final answer, is just the square root of 1 minus x squared. So don't let the fact that there aren't numbers there throw you off. X is the same as x over 1, and sine is opposite over hypotenuse. So that's why I got the 1 for the hypotenuse there. Pretty straightforward. Just remember, start on the inside and work your way out if you have to. Make sure that you are drawing your pictures in the right quadrants based on whether it's positive or negative, and make sure you're taking into account where those inverse trig functions exist. We'll see you next time. Thanks, everybody. Take care. Bye-bye.